Okay, so for our inflection, we want to find second derivative. So x to the fifth becomes 5x to the fourth minus 15x squared plus 6. And then taking the derivative again, that gives us 20x to the third minus 30x. Let's see, 20x to the third minus 30x. Okay. Then to find our critical values, we set those equal to 0. Factor out the GCF, which would be 10x. That gives us 2x squared minus 3 equals 0. Set 10x equal to 0. Set 2x squared minus 3 equal to 0. Here, divide both sides by 10. You get x equals 0. Here, I'll take the negative 3 over. It becomes positive 3. Divide both sides by 2, and you get 3 halves. Square root property says drop the squared, put a plus or minus square root on the other side. And they said a decimal is fine. Rounded to 2 decimal places. So, square root of 3 halves, 1.22. Oops. Question is whether those are actually inflection points, though. We can't just assume they are. Negative 1.22, 0, and 1.22. Okay, clear over here is negative infinity, clear over here is positive infinity. We want to choose test cases, something between negative infinity and negative 1.22, like negative 2. Something between negative 1.22 and 0, like negative 1. Something between 0 and 1.22, like 1. And something greater than 1.22, like 2. We want to plug those into our second derivative. In this factored form here, it'd be fine. So if I plug negative 2 in here, I got 10 times negative 2, which is negative 20, so that's negative, times, if I put negative 2 in here, negative 2 squared is 4, times 2 is 8, minus 3 is 5, which is positive. Negative times a positive is negative, which means it's concave down. If I plug in negative 1, 10 times negative 1 is a negative. And if I plug in negative 1 here, negative 1 squared is 1, times 2 is 2, minus 3 is negative. And negative times a negative is positive, so this is concave up. We don't care about the actual value, we just want to know what the sign is. So 1, if I plug 1 in here, 10 times 1 is positive. And if I plug 1 in here, 1 squared is 1, times 2 is 2, minus 3 is negative. Positive times a negative is negative, so that's concave down. And if I plug in 2, 10 times 2 is positive. 2 squared is 4, times 2 is 8, minus 3 is positive. Positive times a positive is positive, so this is concave up. So these are indeed inflection points because the concavity changes at each one of those. And that's how they get these three values.